So we'll continue from where we had left. So what we did, benefits of OOP, features of OOP. So we were talking about object-oriented programming, and C++ is not only the language which is object-oriented. There are other languages also which follows object-oriented programming. So object-oriented programming is the core component of C++. Object-oriented is used in C++, Java. So it's core component. So we have seen the benefits of OOPs, features of OOP. Now we are going to see C++ as object-oriented programming. So OOP programming techniques are the best ways to develop large complex software applications and systems. So to develop an application or to develop a system like operating system. So object-oriented programming technique is the best way. C++ can be used both as an object-oriented programming language, which is OOPL, here they have determined, and simply as a better C, because the C++ has evolved, sorry, C is evolved to C++. So it's a better version of C language. So C++ programs and operating system, even the Windows 10, some of the parts are being coded in C language. So C++ programs are fast and efficient. Now we are talking about C++ with respect to object-oriented programming. So C++ uses what? Templates. See here this term templates and this generic programming, they work together. So this templates and generic programming is not in much detail we have to learn here in C++, but static polymorphism and dynamic polymorphism. So polymorphism has different types. It is of two types, static and dynamic polymorphism. So static is compile time or late binding. The another term for static polymorphism is compile time polymorphism. Compile time means when the memory is allocated to a variable, when the compiler compiles the program. What happens when we write a program? First we compile it. The compiler checks each and every statement, and after compiling we run it. So compile time and run time. Run time means currently when the program is in execution, and compile time when the compiler compiles the program, it finds out is there any error in the program that time. So the static polymorphism is compile time and dynamic polymorphism is run time. The another term for dynamic polymorphism is runtime. So these two things we will be learning in detail, not the templates and generic programming. Inheritance. This also we will learn in detail. I had given an overview of what is inheritance. Here it is written data binding and encapsulation. So I believe that instead of binding, it should be hiding. Data hiding and encapsulation. So I had discussed data hiding also and encapsulation also in previous lectures. So, and yeah, binding, when the term binding is there, so there are two terms, late binding and early binding. So this late binding and early binding we will be learning in dynamic polymorphism. So these two terms, so I don't think it should be binding, it should be hiding. And if binding is there, so it might be talking about late binding and early binding. So that we will be learning in dynamic polymorphism. Another term for dynamic polymorphism is runtime. Runtime polymorphism. So the C++ uses templates. Generic, that means generic programming. That means general. When there is a function, just I'll give you the overview. We don't have to do it in much detail. So a function, generic programming and templates helps us to create a function which returns a value of different data types. That is, same function is needed, but the value which will be passed will be of different types. It's not specific. Every time the value which will be passed will be different. Like first time it is passing integer value, and at another time when it wants to pass the value of double, that time templates and generic programmings are used, and that we don't have to do much in detail here. So the C++ uses templates, static polymorphism, dynamic polymorphism. These two we will learn in detail. Inheritance, generic programming. Inheritance will learn in detail. Data handling and encapsulation, which covers most of the object-oriented concepts. So C++ uses all these, which covers most of the object-oriented concepts. Also, C++ supports a programming technique that allows memory management to be safe and implicit. So this C++ supports a technique which helps allow us to manage the memory. See, when we have declared a variable A, when the program ends, the memory allocated to variable A will also be deleted automatically. Automatic garbage collection, you can say. Automatically, the variable can be, the memory can be allocated to the variable, and the memory allocated to the variable can be deleted automatically. But we can explicitly allocate memory to a variable, and we can explicitly delete the allocation of the memory allocation of the variable by using the two keywords new and delete. This we had learned in 11th, and I will repeat it if required. I will definitely tell you the use of new and delete keywords, which implicit and explicit terms I had explained you. Implicit, which is automatically done within the system. Explicit, the user has to specify it from external source. So to allocate a memory to a variable explicitly, we'll have to use new and delete keyword. So this technique, programming technique of C++, allows memory management to be safe and efficient. And implicit. Implicit means you got it? Apne aap. Automatically it does. In combination with the use of templates. So the templates which I had talked about, templates and generic programming go hand in hand. In combination with use of templates, constructors and destructors enables the C++ programmer to use programming and design techniques that are more advanced than what is okay. So constructors and destructors we will be learning in detail in this chapter. So what it's trying to say, with templates, constructors and destructors are used in C++ programming. Now, applications of object-oriented programming. Here we are not talking about C++. We are talking about object-oriented concepts. Where these object-oriented concepts are applied, actually where they are used. There are a number of areas in which OOPS concepts can be interpreted and applied. Major application lies in the design of graphical user interface. What is graphical user interface? Can anyone tell me?
Yes.
GIF is the extension of an image file. I'm talking about GUI, graphical user
Map like
interface.
Windows.
Windows, how can a Windows be
Like
graphical?
we can first, like in first time when the computer came, there was black and white screen. There was nothing like graphically shown. There were no colors. We cannot move in that area. We just have to type some commands and do the whatever work we have to do. But now we can click on the window, like on the files.
Okay, correct. So what he was trying to say was that before, when I had to enter in a file, like if I want to go in a C drive, we were having black screen, command screen, in which I'll have to type, we all had to type the command to enter in the C drive, or to enter in a directory we were required to type the commands. Okay, but now what we do? We directly go to the C drive, we double click, we enter. So the user can easily interact with the window. So graphical, all the graphics are present on the windows, buttons, text boxes. Okay, so that is graphical user interface. So the object-oriented concepts can be used in the design of graphical user interface. C++ can be used to develop a graphical user interface. In case of real-time business applications, real-time business application, you can say real-time, that means when the program is in execution, currently working. So a software which is working in the real time. For example, I order something online. So if there is only one stock available, and before me ordering that, someone else orders it. Like I log in before the other person, but I did not order it. That item is present on the screen. But in the meantime, the other person logins and orders the item, and that item goes out of the stock because only one stock was available and I did not order it. I have that item present on my screen, but I did not order it, and in that time the other person logins and orders that item. So what happens? The item is now out of stock, but if data will not be updated in real time, in the current execution time, then the customer will think that stock is still available and that person will order it. So you understood what is real time. So business application, it is somewhat related to business. So this was an example of real time business application, which the applications which do analysis on the data. So in real time, in quick time, it should analyze the data and show the result to the customer. So this is what it is talking about in case of real time business application, real time business apps, you can say. OOP are mostly used. So in those applications, OOPs are mostly used since it is capable of handling complex problems and strong features. Its important role lies in design, maintenance, and modeling. So it helps us to design complex systems, maintain complex systems, and model the complex systems. Recently, it is moved into analysis of system to be designed. So the object-oriented concepts helps us to analyze the system which is to be developed, analyze an application which is to be developed. So it helps us to analyze that system also. It also provides strong automation support. See, CAD is computer aided design. This is mostly used to design, which helps to design 3D design of a car, you can say. So engineers, what they used to do before, they used to take pencil, scale and all, a sheet of paper on which they used to design. But computer aided design, this is an application which helps us to design 3D designs. Okay. So it also provides automation support. Automation, few things it automates within the, automation, what it means exactly here. When we type on Word, so I sometimes what happens, we misspell the words in a sentence. So it automatically shows us the suggestion. So that is automatic. So CAD is also an application which designs the 3D, which helps to design 3D structure, and it provides automation support in these software. So OOP provides strong automation support in CAD. This is CAM, computer aided manufacturing. Computer aided manufacturing means in a factory, a computer is used to run, to give instructions to a machine in the production process. You know, not the hand which picks up the item, keep it some other place, like that. So that hand is, mechanic hand is controlled by this software. Computer aided manufacturing, this is known as computer aided manufacturing. Computer integrated manufacturing, so CAD and CAM come under CIM. Computer integrated manufacturing means the entire production process of an item is controlled by the computer. So CIM system. So OOPS provides strong automation support in CAD, CAM and CIM systems. It maintains object-oriented databases. So you know, database is used to keep record. So same example I will take. If I have an online application on which the users can order their items. So which user has ordered which item, to which address this item should be delivered. All this data, where it is stored in a database. There are multiple databases There are different types of databases. One of the database is object oriented database, that is known as OODBMS, object oriented database management system. So the object oriented concept is used in database also used in AI and expert systems, artificial intelligence and expert systems also object oriented concepts are used. Here I'm not talking about only C++, I'm talking about object oriented concepts. The object oriented concepts are what? Inheritance, encapsulation, polymorphism, data hiding. All these are the concepts which we have discussed till now. All these concepts are applied on these areas. So these object-oriented concepts are used in artificial intelligence. AI is artificial intelligence and expert system. Artificial intelligence, you know now, the robots simulates the human brain, you can say. Artificial intelligence. Expert systems is also an artificial intelligence system, but that system is expert in a particular area. That is known as expert systems. For example, there is an AI which is built only to play chess. It is expert in playing chess. So that is expert systems. So expert systems are nothing but AI only, but they are expert in particular areas. So this object oriented concepts are used in AI and expert systems, used for simulation. Simulation, you know, to imitate someone. So the AI actually imitates human or any living being which humans develop. They are always related to some living being only. Monitoring, you know what it's talking about. Hospitals, it monitors the heartbeat of a patient, so that is monitoring. And modeling of real time systems, you know now what is real time system by now, which is working in actual time. For example, air traffic control systems, real time air traffic control systems, which helps to control the traffic of the aeroplanes. If there is any problem in the air traffic control system, many lives are on the stake. You understood what is real time system. If the if the system is not able to give what is expected from that system, there are chances that lives are involved in that. So real time systems. So the OOPS concepts are used in artificial intelligence, an expert system used for simulation and monitoring and modeling of real-time system. This was actually the applications of object-oriented concepts. Now, object-oriented terms and concepts, most of the terms so we have seen already. We'll just go through the theory. Objects. I don't think it's required for me to explain you again what are objects. Just we'll read what's written here. Objects are the physical and conceptual things we find in the universe around us. Hardware, software, documents, human beings, and even concepts are all examples of objects. Example: script writer, financier, actor, actress, spot boy, lyricist, choreographer, dress designer would all be the objects a film director might consider in directing a movie. So my big problem was to direct a movie. So to direct a movie, who all are required? Scriptwriter, financier, actor, actress, spot boy. So all these are same thing it is talking about. So a class, there is a class movie, and for movie multiple objects are required, and those objects are scriptwriter, financier, actor, actress, and so on. Likewise, a software engineer would consider stacks. Stack is a memory, I had told you. Stacks and queues. These are the two memories, two types of different memories. Stack follows last in, first out. LIFO. Queues follows first in, first out. So it's a type of memory. How the memory is used while allocating or deallocating the data to that particular memory, stacks and queues. So a software engineer would consider stacks, queues, windows, and checkboxes as objects. So software engineer means the person who is designing, who is creating a application. Let it be desktop application or web application. What are desktop application? Those application which runs on desktop. Web application, those application which work over the internet. So a software engineer would consider all these things. So they are called as runtime entities in object oriented systems. Runtime, I have told you the term meaning of runtime. In the execution time, while the program is in execution, which is in use, that is runtime. They are also called as class type entities. That means the object are known as class type entities because they belong to a particular class. There are even called as instance of the class. So the other term for object is instance of a class, or you can say it's a variable of a class. These are the two terms used for objects: instance of a class, variable of a class. They are used to access members, data and functions of a class. So this sentence, I hope it's clear to you. We have seen what is data, members and functions of the class. So objects are used to access members. What are the members? Data, members and member functions of the class. One more thing I want to tell you is, when we had learned data types in 11th standard, built-in data type, user-defined data type, derived data type, built-in was further classified into integer, character, floating, float, double, void. User defined, in user defined there was structure, union, class, enumeration. In derived, array, functions, pointer. You remember the diagram, the classification, and also we had done a table on data types. Questions based on data types is very important. Questions based on data types which you had learned in 11th standard might be asked in 12th also. So there are few topics which can be asked from 11th standard. So when you'll go through the data types, in that you will come across class. Class comes under user defined data type. It is user defined. The programmer defines the class, the programmer creates the class. That's why the name given user defined, because user defines the class. So it is user defined data type. So class is a data type, like int is a data type, double is a data type. Likewise, class is also a data type. Data type of what? Object. I told you object is a variable of class. So if object is a variable, then object should have a data type. So the object should have a class. Class is a data type. Class is a user defined data type. I will take the same example which we had discussed. See, this is a data type. Sorry, this is a variable whose data type is int. When we created an object of a class, so what I'm telling you is, object is a variable of a class. So this object should have a data type. Data type is a class, user defined data type. So class ABC is the data type of object obj. Is that clear? So we'll go through classes. What is written? We have seen what is class. Let's read what's written here. Up till now, we have seen built-in data types. Built-in data types like int, float, all these are built-in data types. Derived data types, we have seen arrays, functions, even we had discussed pointers also in 11. So we have till now seen built-in data types. Those are already known to compiler. So if I'm using int here, if I'm using int, the compiler knows about it. It's already built in. It is already built in the library. Compiler knows about it. But if I want to give data type to a object, I will have to define it here. That is what it's trying to say here. Class is said to be user defined data type. As I have told you, class is said to be user defined data type, which is defined by the user. User defines it. Users of object-oriented technology usually think of classes as containing the information necessary to create instances. That is, instances like object. Instances means object. That is, the structure and capabilities of an instance, that is object, is determined by its corresponding class. So I hope this statement is clear to you. This I have explained you through example also. Classes serve as templates for the creation of the object. Even I had explained the meaning of templates. Okay. So classes serve as templates for the creation of objects. So let's see here what's written. From object-oriented point of view, class provides entire set of data and related functions. Data members and member functions, you remember? That's what it's talking about. Class provides entire set of data and related functions to be made user defined. Thus, programmer can build number of classes according to requirements. Thus, we can say a class is a pattern, or you can say it's a template, or you can say it's a blueprint for a category of structurally identical items. The items created using the class are called instances. It's talking about objects. Whenever class is used to create objects, process is known as instantiation. I told you when you create a class, here we had created an object, sorry. Here we had created an object. So the process of creation of object is known as instantiation. Instantiation of the object. Instantiation has two common meanings, a verb. Instantiation is the process of creating an instance of a class, creating an object of a class, and an instantiation is an instance of a class. Instance of a class means object of a class. Operations or methods. Operations, the another term for operations is methods, another term for methods is functions. You remember member functions of the class? So that's what it's talking about. Or you can say message. The objects can communicate to each other. A class can have multiple objects and those objects can communicate to each other with the help of messages or with the help of functions. A message is a request to an object to invoke one of its method. An object can call one of the methods, like here we had seen. If I wanted to call this function, get data, here the object can call that function. How it can call the function? The object name, dot operator, and the function name. A message therefore contains the name of the method. Name of the method means name of the function and name of the function. Second is the arguments of the method. Arguments means parameters. So here also if you want to pass some parameters to this function, that is also possible, and we will see that example how we can pass parameters or you can say arguments to a function. We had seen a pass by value, that we had seen with simple C++ program, how we can pass a parameter or a argument to a function. In object oriented also, when the object calls a function, we can pass the parameters or you can say arguments to a function. A method is associated with a class. Of course, same thing, it's repeating in different sentences, which I had told you in example with the help of example. An object invokes a method as a reaction to receipt of a message. Also, many objects communicate with each other via methods. Data binding and encapsulation. This also I've told you what is, instead of data binding, it should be data hiding. I have explained you what is data hiding, what is encapsulation. Inheritance. Inheritance, I had told you what is inheritance. There are two classes, class 1 and class 2. And class 1 has its own properties, class 2 has its own properties. Also, class 2 wants to have all the properties of class 1. So there are two ways class 2 can do. It will declare and define all the properties again which is present in class 1, or class 2 will inherit all the properties of class 1. So second one is better. I'll not have to do the same work again. Less memory will be used. So inheritance can be defined as the process whereby one object acquires characteristics from one or more other objects. Some object-oriented systems permit only single inheritance. Single inheritance means a parent and a child. The child will inherit the properties of parent class. That is single inheritance. There are many inheritance possible, multiple inheritance, hybrid inheritance, that we will be learning in detail. So that's what it's saying. In some object-oriented system permits only single inheritance in which it will have only one parent and one child. A situation in which specialization may only acquire characteristics from a single generalization. For today, we'll stop here.